rational exponents means your exponents won't be squared or cubed anymore. They will be fractions some of the time. That's what rational means. So a lot of the homework, you're just going to be writing the same expression two different ways. So they may say write in radical form. And so they're going to give you a to the 1/4. So again, we have a fraction exponent, which you haven't seen before. You can write that either in exponential form like that, where it has an exponent, or you can convert that over to radical form. Your a is still the base number. Now you have a radical, and this bottom number, which is the 4, becomes your index. So whatever the fraction is, the bottom number becomes your index for a radical. So some of your homework really is that simple. They just want you to write it two different ways. So if you had a to the 3/5, and they want you to write it in radical form, obviously you're going to draw the radical. Your base is still a. What would our index be for this one? The index, just the bottom number. So we just have 5, the 5th root, the top number stays as your exponent. So we have the 5th root of a to the 3rd for that problem. So again, if the directions say write it in radical form, you're going to be given something like this, and you write it like that. And they'll also do that in reverse, right, in exponential form. And then they would give you a problem like the cube root of y. So you can write your y, it's still your base, and you're going to have a fraction for your exponent. So what is the exponent that's here with the y right now? A 1, so that becomes your top number, and the index becomes your bottom number. So the cube root of y is the same thing as y to the 1/3 power. One that you'll see a lot, especially any of you that are going to take more math above this one, the square root of x. So what would your exponent be there? 1/2. They will use that a lot. There will be a lot of times in later math classes where you will have the square root of something. You need to know that's something you have to have memorized. You'll see that a lot. Just know anytime you see a square root of something, you can also write that as x to the 1/2 power. So after you've done a couple problems like that in the homework, then they will just want you to evaluate, just do some of them. We'll do 16 to the 1/4 first. So the reason that we've covered this in the past is we didn't have the calculators that could do, how would we switch this to radical form, for instance? Be the 4th root of 16, or it could have been, just write this off to the side for example's sake, the 7th root of 242. I don't know what that is, but we didn't have a calculator that could do the 7th root of 242. So we did have a calculator that could do exponents. So we had to do this in the past. We had to switch that to 242 to the 1/7 power. That's the only way we can use our calculator to solve it. We don't really have that problem anymore, but I still wanted to go over this section to show you how to move them back and forth, because again, later, stuff like that x squared or square root of x will be important. But for this section today, since your calculator will do either one of these for you, I don't really care. I will not be very strict on the work that you show for these problems. It doesn't matter to me which way you do that. If you want to type 16 to the 1/4 or the 4th root of 16, either way is fine with me. What is either one of those? your answer be? What? Calculators might be nice. Maybe if we participated in class a little bit, we'd have a clue what's going on here. Some of us do. Would be 2, either way that you write that. And again, whichever way you want to write that out, it doesn't matter to me. You will have to do a step. The actual example in the book was -1/4. I do want you to show me that step. If you type that in your calculator, it will give you the correct answer. But that is where I'll be a little more specific on how much work that you show. What do we have to do if we have a negative exponent in the top of a fraction? In order to make it positive, what do we have to do? Not necessarily flip, but if it's in the top, we must put it in the bottom so that it becomes positive 1/4. So we've covered that. A lot of the rules in this section you'll have to have remembered from previous sections. And then I wouldn't care if you type that in or however you do that. But this step you would have to show that you know that's a negative in the top, it's got to go to the bottom. I will be specific on that. This part, not so much. That's how you get 16 to 1/4. Same with the next one, 243 to the 3/5. Again, you can type that in your calculator just like that, or you could do the 5th root of 243 to the 3rd. Either way, doesn't matter to me. What do you get? 27. Some of the later problems won't be as easy because you can't necessarily type them in your calculator. X to the 1/5 times x to the 4/5. For instance, you cannot do that. You can't type that in your calculator. So you have to remember, what do you do with those exponents? When you multiply with the same base, which is what you're doing here, what do you do with the exponents? Add them. So that would give you x to the how many fifths? 5/5 or 1. So x will be your answer there. But again, if you don't remember that rule, what you do when you multiply with the same base, that's going to be pretty difficult. Y to the 1/7 times y to the 3/7. Again, same problem. Multiply the same base, add the exponents, and you get y to the 4/7. Pretty simple if you remember. X to the negative 3/4. Yeah, like that in your calculator. What do we need to do with that? So we need to put 1 over x to the 3/4. Very good. It's got to go to the bottom. Yeah, you could do some more stuff to it, but right now. So that we find leave your answer in that. Let's go ahead and look over at some more problems. I might add a few more things to that. Might not. We'll see how it goes. (17 through 30). Paul. 35 40.